increase my end of fiber detection threshold to test past that. So what this means is anything greater than 5 dB, call it the end of fiber. Of course, if you have a 14 dB loss, that is not the end of fiber. That's just a splitter loss. So we can change that. Typically, I'll leave this alone unless I absolutely know that I need to change it. If I want to set any thresholds, pass-fail thresholds for connectors, for splices, I can do that based on wavelength. So in this case, I'll just leave everything at default. We don't need to go through it all, but this is where you would do that. So essentially what I did was I went in there, did a quick auto test to determine the length of the fiber and to null out my launch cable. We've done both of that. I went into the identification to name my fiber. I've gone into the test configuration to input any advanced configuration settings that I would like. So the only thing I have left to do is select both of the wavelengths that I want to test and then optimize these settings. So here is how I shoot an OTDR trace. I will select both wavelengths. I will hit auto and I will start a test. And essentially what I'm doing is I'm letting the OTDR determine what it thinks the best settings are. So it will set the range and the pulse width based on those. And so this is a good starting point for me. So I start off with auto, then I tweak from here. So I can already tell that I'm not using the most optimized resolution here. And so auto decided to use 40 kilometers for both of these wavelengths. So at this bottom graph display here, we go all the way out to 40. But my end of fiber is right here in the middle, just under 20 kilometers. So I can get away with setting this to 20. So I would set both wavelengths at 20 kilometers, and this will push this number all the way out to the end of the display. I don't need to touch this anymore. Pulse width is the length of the pulse. The longer the pulse width, the further you can test, but you sacrifice resolution. So the further you want to test, the further apart the events need to be detected. So one thing that I always like to say is if I can see an event at 30 miles, there's no way that I will see a splice 30 feet away from my OTDR. And so, and conversely, if I can see a splice at 30 feet, I probably am not seeing one at 30 miles. And so you need to be able to optimize this pulse width. The OTDR selected 100. I want to get this as low as I can and still have a nice clean trace. So I will drop this down to 50 and then retest. So for duration, I'll leave it at 5. This is how long you want it to average out. I'll go and hit start and then let it run a test. So you'll see that the distance or the range is nice and optimized. Again,